Hello students, I am Dr. V. Sadhana, Assistant Professor, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. This is a video in microprocessor practicals to explain how to write a program in MUP8085 and also how to execute the program by your own. Here I have taken two examples, addition of two 8-bit numbers with carry and without carry, to explain it. In first program, you can add two 8-bit numbers without carry. If you give with carry, that is higher numbers, it won't show the carry. Only you can view the last two digits. So we have to perform a separate program for adding two 8-bit hexadecimal numbers with carry. This is the flow chart for the program. First, start the program. Now we have to set a register C, which is initially at 00. We have to nullify the register C. After that, we have to get two datas. So here we are using some other method to store the data. In first program, we have stored the load the accumulator from the memory, and here we are using some other technique that we are stored in the HL pair, and from the memory we can acquire the data. Set pointer to get data from memory, and then get data 1 into accumulator. Now the pointer can be incremented. That is, a HL pair can be incremented. The address in HL pair can be incremented by 1, and now the second memory space can be used to store the data 2. Now if carry is equal to 1, so adding to these two datas will provide you whether there is a carry or not. If there is a carry, then it the register C can be incremented by 1. So now the value of the register C is 1. And if there is no carry, you can directly store the sum in some other in the output address and store the carry. Carry is 0 and stop the process. If yes, then it adds the carry, incremented the carry by 1, and again it stores the sum and stores the carry as 1, and it stops the process. This is the program for addition of two 8-bit hexadecimal numbers with carry. First instruction is LXI H, 8201. Here the HL pair contains the address 8201, which carries the data 1. Now move immediate C, 00. This is the instruction to clear the register C. That is, move immediately the data 00 to the register C. Next, move A, M. Here M is a memory. That is data in the given memory. Now the data in the given memory, that is 8201, is now transferred to accumulator. First data is transferred to accumulator. We have to load the second data, INX H, increment H. This means the memory address is incremented by 1. That is 8201 is 02. The data, second data is in the 8202. Now add M. It means that the content of M, now M is 8202, is added with content of A. It is the first data, and it is stored in A, accumulator. After addition of these two numbers, the we have to check whether there is a carry. So if there is a carry, then the carry flag will be 1. If there is no carry, the carry flag will be 0. So we have to check it now by using the instruction jump if no carry, J and C ahead. If there is no carry, it proceeds to ahead, that is the instruction labeled with ahead. If there is a carry, it proceeds the next instruction, that is again it if there is a carry, it skips the instruction. Next it goes to next instruction, that is INR C. The carry register C is incremented by 1. Otherwise, if there is no carry, it jumps to the label ahead, that is increment H. So the memory address is incremented by 1, that is now MS8203. Move M, A. The resultant is in the accumulator now. It is transferred to 8203. Again increment H, INX H. That is the memory is incremented by 1, 8204. This can be used to store the carry. Now the carry is in the register C. So move M, C. So the carry can be stored in the address 8204. Then stop the process. Here we can execute using Intel 8085 simulator, similar to that of the addition program without carry. Again reset exam memory, starting address 8000 and proceeding all the opcodes, feeding all the opcodes. Then we have to feed the input, that is input is in the 8201, the first input 54, and 8202, the second input 8A1. Output table and the calculation is provided here. First input is 54 and second input is A1. It gives a result F5, which can be stored in the 8203, and the carry as a 0, and it is stored in the 8204. So it can be verified by writing the binary values for each hexadecimal number, and adding will provide you the resultant as F5, and it is verified. Thank you all.